Now we are going to solve a probability related problem. What is the problem? The demand of milk in a certain locality follows Erlang distribution. If average demand of milk is A liters, average demand of milk is A liter, and most likely demand is B liter, and B less than A, then find the variance var x of Erlang variable x. As we know that PDF of Erlang distribution fx equal to lambda to the power k e to the power minus lambda x, x to the power k minus 1, and gamma k, where x greater than 0. Okay, otherwise 0. To get most likely demand, we have to show that if fx is maximum or minimum. In case of maximum value of fx, the value of x is most likely demand b. Okay, differentiating fx with respect to x, f dash x lambda to the power k by gamma k, e to the power minus lambda x, differentiation of e to the power minus lambda x, minus lambda into e to the power minus lambda x plus x to the power k minus 1 plus e to the power minus lambda x into k minus 1 x to the power k minus 2. For maximum or minimum value of fx, f dash x will be 0. Therefore, lambda to the power k by gamma k into x to the power k minus 2 into e to the power minus lambda x, taking e to the power minus lambda x and into x to the power k minus 2 as common from these two, minus lambda x plus k minus 1. For max or min value of fx, this will be 0. Therefore, minus lambda x plus k minus 1 equal to 0 and x equal to 0. Therefore, x equal to 1 minus k, k minus 1 by lambda. Now, differentiating once again, we get f double dash f double dash x equal to lambda to the power k gamma k u into v into w. Differentiation of this minus lambda into x to the power k minus 2 into e to the power minus lambda x minus lambda plus minus lambda x plus k minus 1 into minus lambda e to the power minus lambda x into x to the power k minus 2 plus minus lambda x plus k minus 1 into e to the power minus lambda x into k minus 2 x to the power k minus 3. Okay, differentiating f dash x with respect to x again, we get f double dash x as minus lambda x plus k minus 1 equals to 0. That means x equal to eto, putting this value into eto, 0 into something out, 0 into something out. Therefore, lambda to the power k by gamma k into x to the power k minus 2 e to the power minus lambda x into minus taking e to the power minus lambda x and x to the power k minus 3 as common from this one is equal to lambda to the power k by gamma k into e to the power minus lambda x x to the power k minus 3 minus lambda x minus lambda x plus k minus 1 plus k minus 2 into minus lambda x plus k minus 1. Taking x minus 3, x to the power k minus 3 and e to the power minus lambda x as common from this one. As minus lambda x plus k minus 1 is 0, therefore these two are 0. Lambda to the power k by gamma k all are positive, as it will be greater than 0. minus lambda x. That means lambda x minus k plus 1. K must be greater than 1, therefore it will be less than 0. Therefore fx has maximum value. Therefore the value of x will be most likely demand. Less than 0, fx has max value. Therefore k minus 1 by lambda x is equal to b. Therefore lambda b equal to k minus 1. As we know that mean of Erlang distribution is k by lambda. It is equal to a, and that of variance is equal to k by lambda square. That means k by lambda into 1 by lambda. That means a by lambda. From this one, k equal to a lambda. Putting this value into lambda b, a lambda minus 1. Therefore a lambda into a minus b equals to 1. Lambda equal to 1 by a minus b. Therefore 1 by lambda is equal to a minus b. Putting this value into this one, a into a minus b, which is the required variance. Okay. Any doubt, please comment me. I will clear your doubt, and thank you for watching this video. Okay.